Welcome to episode 4 of Breaking the Ice. My name is Connor.
And my name is Rebecca.
And we are your co-hosts.
This week, we're tackling the issue of construction in the north. In Canada's territories, the Yukon, Northwest Territories, and Nunavut, there's a critical lack of adequate housing. Houses are in shortage, expensive, and often need of serious repair.
One individual in Nunavut has reported looking for 14 years for a house to live in with his 5 children. Instead, he's had to spend the past 8 years living in a home with 13 other people. But now let me give you some statistics that illustrate just how bad this housing crisis has gotten. The share of homes in Nunavut requiring major repairs doubled from 20% in 2006 to 41% in 2018, while the Canada-wide average is only 7%. The territory now requires 3,000 housing units to catch up to existing demand, while the government is not on pace to do that. 35% of houses do not have enough bedrooms compared to only 5% across Canada. Exposure to mold, malfunctioning heating, and other challenges can make for unsafe living conditions. And in 2018, people in the territory even reported developing sores due to black mold in public housing units.
There are many reasons for this crisis. One of them is that building in the north is very expensive, and maintaining existing units is costly too. In fact, the average annual cost of maintaining a social housing unit in Nunavut is over $26,000.
The 2021 budget earmarked $25 million to help the government of Nunavut, quote, try to attract money from the National Housing Policy. However, this is inadequate. Changing permafrost levels mean that many houses will need to be rebuilt from the ground up, in addition to new housing units that must be constructed. So today on the show, we're looking at an alternative solution to what's being done now, innovation. From Svalbard, we'll hear about construction techniques that might be used to lower costs and increase the supply of housing in the north, including new techniques for building on permafrost. We'll even hear about the possibility of 3D printing new houses. We need to build differently, build better, and start building now. Svalbard is doing this by building houses designed to last 100 years.
I spoke first to Stig Hansen, who is the project manager for a new student housing complex being constructed in Svalbard, Norway. We discussed the unique challenges of building in the north and what is being done in Norway to address that. Hopefully Canada can take some lessons from his testimony.
And later on in the show, you'll hear my interview with Julian Bell. He's a mechanical engineer who specializes in robotics, manufacturing, and mechanical design. In 2017, he worked on a project at MIT to construct houses using 3D printing techniques. While this technology may not be applicable immediately, it's a great foundation to build on later, which could be used in the north. Now let's get to Rebecca's interview with Stig Hansen.
Okay, so the first question I have is just for our listeners who may not be familiar with Svalbard. Can you tell them where it is and generally sort of what life is like there?
Yeah, Svalbard is a small town far up north. I think it's the northernmost town in the world. It's between the mainland in Norway and North Pole, just in between. So it's only 1,000 kilometers from Longyearbyen city, where I live, up to the North Pole. So we are on 78 degrees, 12 degrees north. So yeah, and in the winter we have almost 4 months with pitch black, the dark time of the year, and the opposite in the summer. We have 4 months with midnight sun. And we are approx 2,314 people living up here, and it's approx 3,500 polar bears in the same area. So actually, to do if you go outside, you have to be very carefully with the security. In the winter, it's so cold, so you always have to be 2 people on snowmobile or when you walk, and you always have to have a rifle with you. Because the last year we have actually in the last 9 months we have 2 attacks from polar bears.
Could you tell us a little bit more about your personal background and what brought you to this area of work?
Yeah, of course. Of course, I'm from the northern part of Norway, so we have this midnight sun and the dark time of the year. So I'm used to that. I love winter, and of course I'm working with complex projects in the mainland, and this was a complex project. They couldn't send any project manager up here. They have to send somebody who have this kind of a background what I have. Yes, I'm actually a timber from 30 years ago, and then I have this technical school, and after that I have this civil engineering school to have the construction up on the ground, not in the ground. And the last part is I work a lot with this harbor, and have this experience now for 20 years with building in the Arctic and in harbor with a lot of ice. The only changing was now we have the ice in the ground, not in the top of the ground. And of course, I have my uncle was living up here for 50 years as a coal miner. He's dead now, he's dead 5 years ago, but anyway, he told me a lot of the community of Svalbard, this coal mining town, and it's always fascinated me. And my grandfathers and grand for 7 generations there was fishermen, and there was whalers, and hunting sea lions, and for me it was like a kind of fairy tale when I have the chance to go here. It's I feel like I'm a part of this community. I didn't know anybody when I come up here, and now I feel I know like 500 people I can say hello to. We go trips after work, and we do stuff together. So I'm feeling like everybody is taking care of everybody here.
I guess sort of related to that is sort of the effects of climate change. I know that's a discussion we often have when we're talking about the Arctic in general, because it is sort of facing this accelerated impacts of climate change, as we sort of see, especially as we push north to populate more northern communities and areas. I've read that Svalbard is already feeling the effects of climate change fairly drastically. Can you tell our audience sort of what environmental changes have been observed sort of this far, and what impact this is having on the existing infrastructure, and when we're thinking about starting to build new infrastructure?
Yeah, as you know, Svalbard was a coal mining town before, and all the infrastructure up here was temporary. But the last 30, 40 years, the building and the infrastructure is more like it have to be here. And of course, of the climate change, when the permafrost we have in the ground is melting, something happen up here with the infrastructure. For example, all the pipelines for waste, for heat, for water have to be in the air. We have these pillars into the permafrost, and we have the pipelines up in the air. Of course, insulated and heated up with heating pipes inside the other pipes. And when the permafrost, we say at the first 1.5 meter from the top level and down is an active layer. It means during the summer period it can melt. Actually, it's not permafrost anymore, it's melting. And when we do this construction, we have to get the pillar deeper and deeper because of this top level is melting. For instance, my project up here, we have like 8,000 meters with pillars through the permafrost and into the bedrock. Because when it's melting, it's not, it will melt. We have to have our building project to steady ground. This is what we do to think forward. But the big problem right now, we are the second big project up here where we do that for the whole city. And the rest, all the buildings are moving. They are melting with the permafrost. So you have a lot of cost with the maintenance. So I think for the next year to come, all of this city have to be rebuilt because of the new climate change, all the city.
Do you think that there's the capacity to do that, or do you think there will be a rush to do this as it's happening?
I think, it's my opinion, it's a combination between two things. One, we are stopping to have this coal mining business now. This is one thing. And what are the people up here going to live? to do, what to work with. And the government tell us it's tourism, because it's fantastic nature up here. And when you have the tourism, then you need a lot of people to work with that, not only a few. And all these people have impacts on our infrastructure. So we have to start building right now the new infrastructure. This is because of to take care of what's coming up for the tourism, and also to take care of what have been.
I know that one part of your project is embedding sensors into steel in the ground. And I was wondering sort of what do these measure and what information is most important to gain from these sensors?
Okay, maybe it was some misunderstanding, but because we have sensor, yes, but not sensors for sensor. We have what we do here, because of the permafrost, it's difficult when we have the electrician to have it to the ground. You have to have a kind of we call it jording. You have to put it to the ground so you don't have this
like grounding, so you don't get shocked.
So we connected all our pillars to the ground with the electric net, and the power grid we have in town, there it goes a big iron plate to the sea with copper pipelines. So we grounded all the electricity up here. So this is what we have. But when the level, what I think you talk about, it's during the building process. Because, yes, not after, but in the building process, it was measuring where is the water. The problem isn't when everything is freezing, it's no problem. But during last, for example, this November, December, when we started drilling the pillars, they was stuck. They couldn't come down because we have small river underneath the surface. And this, and this river tear down this drilling hole. And then the pillar was stuck. So we actually have to wait for the last January this year. And then everything was frozen, even this active layer. And before this wasn't a problem because everything was frozen. But the last year, it is a more and more problem to build up in the Arctic. Because of the active layer, you have this river underneath. And this river give us a big problem with because up here we have something called pingo problems. And pingo problem is like an ice volcano come up. So the ground is rising, and they can lift the houses up, and you have problem with the ice, and it can grow for 20 centimeters in 24 hours. So our sensor was to find out where are these pingo coming up and how deep is the water. And then when we know that, when we drill, just waited with this hole before we get the pillar downs.
Great, that helps clarify that. Thank you. Is that becoming sort of a common practice when constructing like housing in the north, or is it still sort of a newer approach?
This is a very specific problem, and we don't have this problem in the mainland in Norway, but up here it's a problem. And even up here, and we have our own university to study this phenomenon, it still is a problem. So you have to be aware of that, and you have to take measure to how to handle it when it comes, because one year it can be in one specific place, and the next year it's another place. You never know.
So I guess building off that, so it's sort of a Svalbard specific problem. Do you know any other places in the world?
Yeah, I think this problem should be in any places who have permafrost. Not only in Svalbard, because Svalbard is permafrost, but I think if you're going to build places where you have permafrost, you have to think totally different when you have this construction in the ground.
Do you, you may not know, but do you know of any other sort of companies or initiatives that are doing this in other countries facing similar problems?
Yeah, I heard up here we have a company called LNS. They was our main subcontractor, not the main contractor, but the main subcontractor. And they also work in the Arctic, in Greenland, in Alaska, and in Antarctica. and they are used to this kind of problem. But their the Arctic main office is up here, so they're used to this kind of situation and to work in this kind of situation.
It sounds interesting. It almost seems like you need to have that lived experience or experience it sort of directly in order to understand it properly and to actually make the moves to deal with it.
You have to have when you do the groundwork, you have to have two main experience. For me, for instance, I was used to build harbor in the mainland, and we was drilling these pillars all over in the sea, in the land. And if you know how ordinary drilling happen, and then you take that experience up here, and you take this experience from the local when you have this pingo, and you combine these two experience, and then you can build up here. And for us right now, we know about these problems and we solve them. When you don't have you have to have a good time. You can't rush the time schedule. You have to put time in the time schedule to deal with this problem. If you don't, the project will be a failure.
Mm-hmm. I think, yeah, that focus on time is important because I think, at least in Canada, our experiences, we're catching up with climate change, right? Like we're sort of already behind trying to deal with the effects we're facing from climate change. So given that it takes a while to actually go through this process and do it right in construction, yeah, it's important to start thinking about it as soon as possible.
In my experience, so it's like time is money. Okay, that's one part of the problem. But when you build up in the Arctic, you have to understand that it takes time to build properly. And you have to put this extra time it takes in the time schedule plan. And if you don't hurry that, then you have a solid project and a good fundamentation. But if you hurry that, you have extra work after the project is finished. So you have to think of this problem in advance.
One question I sort of have is related to sort of the mining history of Svalbard, and what is sort of the experience like nowadays? Is it really just predominantly focused on tourism? Was there sort of like a dip in like the economic viability of Svalbard that sort of faced almost like a mini depression after sort of mining stopped in the region? Or has it always sort of been able to sustain itself?
It was, I think it was 5-6 years ago, the government, we call it the green shift in our government, and suddenly they decided to shut down all the coal mining industry. What do we do next? And the government say right now we're going to live from tourism up here, and of course we have a university and we have science of what happened in this environment. So the goal now is to make all the island green energy. But in our project to help this, how we fix it, my project is the biggest project in the town here, 9,000 square meters. So we have built it like passive houses standard. So we use very little electricity. And we also build with sun cellars on the roof. So when we have the main structure for energy is ready for us, we can sell our energy we're not using, we can sell it back to the town. So we start already to prepare what's coming, because we know the coal mining is ended in 5 years, it's over. So we start now to prepare us. So I think every new houses right now who is building up here is like passive houses and with sun cellars and other technical solution so you can use less energy as possible.
Yeah, that's great. I wanted to ask you sort of about passive housing and sort of the costs associated with passive housing. Are they greater than sort of constructing maybe like more traditional house that you would see 10 years prior? Or are the costs sort of similar to that, what it would be to construct something else?
So actually, maybe passive houses is expensive to build around the world, but up in the Arctic, as it is on mainland, it's not so big different for the cost. It's we're talking a promille. It's like for our project, it was for the building cost, it was only 100,000 NOK for 9,000 square meters. It's nothing compared to the Norwegian standards back home. But we have a very strictly standard in Norway, how to build houses. So it was only small changing. So to compare it to the mainland, it's not the biggest cost. The cost is, when you build these houses, is the technical system. That's you pay money for that. For instance, the sun cellar system is very expensive. But if you're going to sell the energy back to the town, you need this kind of technology. This costs money. But if you don't do it now, when do we do it? We have to start somewhere. So this project is financed by the government. We call it Husbanken, and they was gladly gave us this extra economy to build this kind of houses. So this is a student house for 352 students, what we are building now.
Do you think that the government support of this project has to do with sort of that green shift you were talking about previously?
Absolutely. So because this is not only like a private project, I think it's maybe it will be more difficult for a private contractor to build something like up here, because it's not it's expensive. But everybody have to take responsibility. So we thought that my client, this Norges Arctic Studentsamskipnaden, take responsibility, and we can be like the first. We go in the front and show the people how we can do it, and then it's more easier for the rest of the company who are going to build houses up here. For instance, it's not allowed for any person to own something here. It's not allowed to have your own ground up here. So this is the politic from Norway. So our Mother Norway is own everything, but you can rent the ground for 10 years or 15 years. You rent it.
That's interesting. I didn't know that.
Yeah, you can't own nothing up here. And then the government have this monopoly. So they can, after this renting, hiring contract is ended, they say, of course, you can have it for 10 years more, but then you have to upgrade your house to passive houses. They can do like this.
Do you think that there's potential, or I guess interest as well, to do sort of more housing projects like this outside of Svalbard into maybe Canada's north or other?
Yes, definitely. I think up in the Alps in Europe, where we have a lot of glacier, and all the area where you have glacier or it's very cold, and where the climate change is so big, and if you're gonna stay there, you have to do something about it. But you have to have, of course, like now we have a small town, but anyway, we are our own community up here, and if you're gonna do this other place in the world, you have to be some kind of business there, or people are living there, and then you can do something about it. For if we didn't start doing something about it right now, I think in 15-20 years you couldn't live in the houses. All the houses was you can't live in them because they move so much, and it was I don't know the name, but damaged because of the melting. So that's why we have to start right away.
Do you think that, obviously you're starting right away and you're focusing on this issue, do you think there's enough focus on this right now, or there needs to be more people working on this issue?
Personally, I mean, we need more people. It's going too slow. Yeah, this is what I see with my own eyes after 1.5 years up here. It goes so fast, and we need more people in the administration. Like we have this municipality up here. They need more people with the background to know about this problem. And we need actually more finance and more workers to fix that. For instance, now in January, where we have in the old part of the town, all our workers was living there on the barracks. before the student was living up in the barracks. We call Nybyen. It's the old part of Longyearbyen. And suddenly now in January, in 24 hours, the whole building was freeze down. All the pipes cracked. It was freezing. It happened suddenly, and now we can't live there. We have to move all the workers to the hotel in the center of town. So I think that part of the old town have to be tear down. It's so old and damaged now, so it's no. We have to take it down is the best, and then we can use all the energy we send up to the old town. We can use it in the center of town, and all the building. It demands so much of maintenance. It will cost almost the same as building new one.
Okay, I was gonna ask, yeah, whether like retrofitting or like changing it to be more sustainable and to deal with the environmental threats is viable, or whether it's just best to rebuild.
Yeah, but actually what is good up here, when we take something down, for instance, old houses who have this problem with the fundamentation, so the crack on the ground, we try to take care of the material and reuse it, recycle it. For instance, the wooden panel we can recycle. We don't need to ship it down, and they started with that as well up here. So we are fixing. You can say we are fixing new fundament, new pipe, new technical infrastructure, and we build it up again. But the exterior we can use again.
Yeah, that's great. Yeah, sort of rebuilding the base, but then reusing some of the other things to actually.
Yeah, exactly. And they already start with this in several projects in town. When they tear something down, they recycle part of the building, what you can use.
Do you think that the recycling of those materials started because of sort of this green push to be more environmentally friendly, not the cost?
But that is only one part of it, because it's very expensive to put all the waste down to the mainland. You can't keep it here. So instead of shipping it with boat back to the mainland and burn it or whatever, we try to recycle most of it here, what we can use.
Those are all the structured questions sort of I have. I wanted to ask you if there's anything else you'd like to mention or talk more about regarding your project or anything related.
Yeah, right now, Oxen, we're looking for that. We have this, as the rest of the world, this Corona situation all over the world. And of course, regarding to that, we have not so much students right now. But before the Corona, we was having approx 1,200 students a year here. Not in the same time, in 5 period of the year. When one student come up here, he was here 6 to 8 weeks, and then go back again. And right now we are building a student home for, we are increasing the capacity from 200 to 352. So right now we push hard to have our first building ready to, the semester is starting 1st of August this year. And now I believe on the deadline, because it's going very well right now on this project. Yeah. So I think it's like this, the houses and the student houses is so good. It actually, like, I want to be a student myself again. It's so nice.
Yeah, it's rare to have a student housing that's actually nicer than.
Yeah, so we tried actually not building only student houses. We are changing this the city. Before, the student was spread around in the outer part of the old city, and now we're moving all of them to the center of city. So the student is it's an important part of the people up here, the students. They are creative, they are the new one, they are thinking more about the environment than we are doing, or I'm almost 50, so they are more up to date. So I think, when they study here and they live in this environment, like it's a greenhouse, it's a passive house, and they also have the smart idea, and they are their future. I think this is very good.
For sure. I know that, yeah, you're saying sort of nearing the end of at least the first phase of construction, which is fantastic. And I don't want to make you already think about the future, but I'm just wondering, like, how long do you think that these new projects, these new housing will remain sort of safe and environmentally friendly? Like, when will they need to be retrofitted next? Like, how sustainable is this housing project?
Yeah, we are using a lot of money on the construction in the ground. So you can say 50% of the length of the house, we have a 32 meter from the ground to the bedrock. And we have a 15 meter over the ground. And we have steel construction all over. So we are building these houses for the worst scenario. If the Longyear River is going out to the sea during the next year because of melting, our house is still standing. So we were thinking 100 years, it's still standing. This is the horizon for this project.
Really forward thinking. Yeah, that's interesting.
Yeah. So you can say all the entrance and bridges into the building is not on the bedrock. It's movable. So only the houses is standing steadfast. So when it starts melting and everything is moving here, it's only to build new bridges into our house. So we have been thinking on that scenario as well.
Yeah, it's great to see, because I sort of, as we've been talking, like, seem to be this sort of cycles where, okay, we have to rebuild, build and rebuild. So it's nice to be disrupting that and trying to find a solution that is longer term.
We was the project group. We was 60 engineers in this group to working together for 1 year and to figure out the solution, how we build it so it can stay here for 100 years with easy measure what we do. And we think we found the best solution for that. Of course, we never know, but technically, we think we solved it. We think we solved it. So the problem will not be that our houses is moving. The problem will be when the infrastructure is moving and the houses is standing. That's another issue. So that's why I was telling you, I think we need more people up here right now to rebuild the technical infrastructure, because it will cost a lot of money, but we have to take the same, we have to build it in the same way what we build our houses in. And if we do it on the same way, then we build the infrastructure one time, and 100 years we can change it again.
Well, that's very interesting. Thank you for taking the time to speak with me. I know I've learned a lot from this, and I definitely just increased my desire to travel to Norway and Svalbard in particular. So thanks for shining some light on that.
Yeah, you have to come, definitely, Rebecca.
Have a great day.
Thank you, bye-bye.
That was a great interview, Rebecca. What was your biggest takeaway from your conversation with Stig?
I really enjoyed learning more about what life is like in Svalbard and hearing about the strong sense of community there. But I think my biggest takeaway is the time-sensitive nature of housing in the Arctic. The rapid rate of climate change requires innovation to occur immediately and cannot be delayed.
Absolutely. Now let's get to my conversation with Julian Leland Bell about how to 3D print a house. I wanted to know, could this technique be used in the north? So I'm very glad to have you on today, and thank you for your time. Maybe we could just start by very quickly telling our audience a little bit about your own personal professional background.
Yeah, absolutely. My name is Julian Bell. I'm a mechanical engineer. I've been working between robotics, manufacturing, and precision engineering for the past 9 years. I came to automated construction through my work in graduate school with the MIT Media Lab, specifically the Mediated Matter group, on a system called the Digital Construction Platform. And the Digital Construction Platform was honestly less of a 3D printer and more of a tool set for folks who think about additive manufacturing, or honestly automated construction at architectural scales. You see lots of folks, particularly in architecture, using conventional industrial robot arms to build really cool structures, albeit at the scale of 1 to 2 meters. We wanted to try to create a platform that would let us work on much larger scales. So through that experience, I met a wide range of folks in the in the automated construction and additive manufacturing for construction communities, folks who know a lot more than I do about concrete mixes, building codes, which is a whole interesting part of this discussion. I think this is an area, I think this is a field that has a huge amount of potential that we're going to see really tremendous growth in over the next decade. And so I tried, even though I've moved on to work in other related fields since then, I try to stay connected to the automated construction and additive construction communities as much as I can.
So a lot of this is based around 3D printing, and I think a lot of people now do know what 3D printing is, but some of our audience might not. So could you just briefly tell them what 3D printing is and how that works?
Absolutely. So 3D printing takes as its basic principle the idea that if you have a three-dimensional shape, say a house, you can slice that shape up into layers, of a consistent thickness, and then if you take each of those slices and you look at it, and you lay down material to cover that slice, build that up layer by layer, you can actually recreate that complex three-dimensional shape with a relatively simple manufacturing process. That's the real genius of 3D printing, is creating these very complex geometries without a very complex fabrication operation. If you think about the way that you build a traditional house, right? You have workers climbing all over it. They're moving lumber into position. One person's holding something, someone else is fastening it in place. That's a very complex job for a robot or for any other automated system to do. It's doable, but it's certainly not trivial. 3D printing, by contrast, gets rid of all that complexity by taking this object, slicing it into layers, and then building each one of those layers at a time. You simplify the manufacturing process enough that a robot, that in the case of a building, a large gantry style printer can produce these artifacts, and so I think that's why 3D printing is interesting in lots of different fields, but especially in the construction field.
The project that you worked on at MIT was applying that process to building houses. So could you tell us what was unique about that?
So, one, as I mentioned, 3D printing is a really good inroad to automating construction processes because of how simple it is from an automation perspective, relatively speaking. Not to say it's easy. So that was part of how we came to 3D printing initially. That simplicity coupled with the freedom of design that 3D printing affords you. With a 3D printing process, you can, for no additional cost, create shapes that are very complex and that would be hard to produce using traditional construction techniques. What set our project apart was the method of 3D printing that we used. Your listeners, if they're familiar with 3D printing, they've probably seen desktop scale 3D printers that basically squirt out a plastic of some sort through basically a hot glue gun and build that up layer by layer to create the part that you take away at the end of your print process. Our process was a little bit different. We replicated what's called in the construction industry insulated concrete form construction as a 3D printing process. We used spray polyurethane foam insulation as our 3D printed material. Instead of printing the house, we printed the formworks that would hold the concrete, which would create the walls of the house. The advantages of this process are, one, we print with a material that's much, much easier to print. Spray polyurethane foam is about as nice of a 3D printing material as you can ask for, especially compared to the challenges of directly printing concrete. Two, we have much more geometric flexibility. We don't have to worry about whether the concrete that we just printed is going to fall off of the side of the house. And three, especially in applications like I think you're interested in, we think that that techniques where you print a formworks rather than print a building are actually much easier to integrate with existing supply chains and are have a much smaller supply chain footprint, which is a really important consideration when thinking about taking additive construction processes to very remote environments, to very challenging environments.
Right. I'm wondering if you could speak a little bit more about the practical application, like you just started to outline a little bit in these remote areas, potentially in the north, but other areas. Why is this easier? You've mentioned that there's a supply chain constraints. Are there other factors that would make this ideal for construction in remote environments?
Yeah. So first I'll take a step back and say, why do we want to automate? Why do we think that automated construction processes are preferable for remote or challenging environments? Well, the most important thing is they require fewer people to execute. Um, you could have with a construction scale 3D printer, you could conceivably have one operator supervising three, four, even up to 10 different machines, hypothetically, all of which are printing buildings. To produce those same buildings with human labor, you would need 10, 20, 50 workers to build at that same rate. Just like with any other industry, finding opportunities where we can have a robot do a job instead of putting a person in harm's way lets us reduce risk for those people. It lets us simplify the process of creating these structures in these very remote, challenging environments. So that's the first thing. Now, of course, it's not to say that just because you have a 3D printer, it's easy to go to the far north, deep into the desert, into the jungle, whatever, and perform a construction project. You still need to figure out how you're going to get the raw materials that you use to build your structure out into that remote, challenging environment. Notably, you don't need to worry about moving quite as much food, quite as many like housing and shelter supplies to support a large construction population. Right, you just have one operator managing all these machines, but you still do need to provide concrete. You need, the case of our process, you need to provide the foam that we use to produce the formworks. You need to provide power to run these pieces of equipment. So within additive construction, there's a whole bunch, well, I should say within automated construction, there's a whole bunch of different processes that have been explored. The most popular one, and I think the one that's achieved the most traction in the marketplace, is 3D printing processes based around concrete in one way or the other. Most 3D printed concrete structures require relatively sophisticated concretes. These are high performance concretes. The raw materials that are used to make them are going to be harder to find in very remote areas or in poorer regions of the world. And that difficulty in acquiring these raw materials is going to make your supply chain tighter. One of the advantages that we saw in our process was by using this spray foam, which is admittedly not an easy material to source in a remote environment, but you need much less of proportional to the volume of the structure you're building to create a building. And then pairing that when you go to actually cast your building into that formworks with just a conventional concrete, whatever's locally available, we believe that we could actually simplify that supply chain issue and make it easier to perform these printing processes in very remote regions of the world. Now, it's important to say that folks are working on this problem all the time. Some of my colleagues, for instance, at the U.S. Army Construction Engineering Research Laboratory, were developing concrete 3D printing processes that could use garden variety, ordinary concretes to print with. They were having a lot of success with that. I think there's a lot of opportunity to continue to explore that area. There are also some other benefits to these formwork printing processes, like what we use, though, that might still make them appealing for certain applications.
That's really interesting. One of the things that really caught my mind about your MIT project was the fact that in the press release, it also said that some of the potential applicants are not just in remote areas on Earth, but actually on other planets and on the moon. And I don't know if you have anything to comment on that aspect of it as well.
Yeah, no, that's we would love to see our 3D printer on the moon someday. We actually have worked with NASA using our digital construction platform to explore some of the questions around how additive manufacturing techniques could be used in space environments to build structures. Practically, I think we're a long way off from 3D printing buildings on the moon or Mars for many reasons. And honestly, I think that we have a lot of opportunity right here on Earth to leverage these technologies for good. For instance, what your team is doing. I always taking a step away from additive construction for a minute. I think that from additive manufacturing for construction for a minute and looking just at automated construction as a whole, I think that there's a lot of opportunity to reduce worksite hazards through the use of automated construction equipment. As an example, when I was in grad school, the facility I was working at was right next to the Boston shipyards, and at the shipyards, these enormous Navy ships sail into their dry dock, and human workers in vertical lifts scrape the paint off the outside of these ships with pressure washers. This is one person in a lift jack doing this for day after day after day, working with noxious paints, pressure washer water, I believe with abrasive grit in it going everywhere. It's a huge mess. That's a perfect job for an automated construction system like the DCP. Even the DCP, which was a research project, was by no means a finished product ready to go out into the market. It could have completed that job. And so I think thinking more broadly than just 3D printing houses, there's all these very low-hanging fruit opportunities to automate simple, dirty, dangerous construction tasks, which we as the automated construction community could take on, and could both make money and keep people safer.
As it stands now, as the technology exists now, are these homes that they're constructing places people would actually want to live in?
Yeah, so the folks at Icon, they are specifically focused on building houses. They're building houses. Yeah, they've got at least one house in Austin, I believe, and they are targeting, I believe, a few locations in Central America, with their 3D printing process. And these houses are not designed to be, well, they certainly have applications in disaster response. They're not designed to be disaster shelters. The one unit that I've seen, this is a beautiful, architecturally interesting, fully featured house. However, I do think that just because these companies are focused on residential markets initially doesn't mean that there aren't applications in remote, challenging environments. I think the major challenges that you're going to face in doing this are, one, supply chain. Like I mentioned, it's much easier to get concrete to Austin than it is to the furthest reaches of Greenland. Two is going to be material performance in these challenging environments. When we were 3D printing our dome with the MIT project, we encountered an interesting failure mode. We were printing overnight. The sun came up, dew collected on the top of our dome as we were printing. And as we were spraying foam, the layer that we had just sprayed failed to bond to the previous layer and actually fell off in these big ropes. We looked at it. We figured out that there was dew at this layer interface and presumed, okay, well, that's clearly that's probably the problem. Let's dry it off. We're up there with towels drying this giant dome off, and let's try again. And it worked. And we went back to Dow Chemical, the company that generously provided us with the foam for this project, and asked, hey, what do you guys think happened here? And they were like, oh yeah, that makes perfect sense from a technical perspective. Right, the water accelerated the curing of the foam. It generated a lot of gas. It basically blew the foam off of the previous layer of the structure. This is a failure mode that nobody would have ever experienced in normal use of this foam, because it's not designed to be used outdoors in wet environments like this. I think for any sort of automated construction process in general, but particularly additive processes where the material composition, the interlayer interactions as you're building up your structure are so important to the performance of your final structure, you would really need to do a fair amount of legwork up front to make sure, hey, is my foam going to extrude correctly when the temperature is 10 below zero or colder? How's my concrete going to perform over many freeze thaw cycles, or when it's extruded at these very low temperatures? Just using your guys' use case as an example. So yeah, I think supply chain and I think material performance analysis in the desired in use environment will be very important considerations for taking these technologies out of the residential markets, closer to the equator, and moving them to more challenging climates.
And if you had to make a prediction for where you think this technology will be in 2031, 10 years from now, do you think it'll be widely used, widely applied in the real world? Or is it still going to kind of be a new, novel, experimental sort of thing?
I don't think that my house will be 3D printed in 2031. Now, with that said, if there is not a company who is 3D printing, say, equipment storage shelters or equipment protection shelters in remote environments like your guys' application area, there's a business that somebody should start, right? If that's not happening in 10 years, then somebody's not making money that could be easily made. I really do believe that the technology exists today to provide automated construction systems, likely automated additive manufacturing systems targeted at construction, which focus on a very narrow set of tasks in very challenging environments. I think that's a great use case for the technology, and I think actually that's where we're going to see it find a home first.
And do you see what are some of the major barriers to widely applying this?
I think the biggest one is honestly regulatory. When I was working on the digital construction platform, one of the challenges we knew we faced when we started exploring with architects, code officials, et cetera, was, if we wanted to print a structure that humans could inhabit, what aspects or what sections of the relevant local, state, federal, international building codes would we have to meet? At the time, and this was 2016, 2017, the answer was you're basically going to have to make this up as you go. And if you really wanted to build a business around this, you would have to start petitioning these organizations to start integrating additive construction techniques into their codes. Now, a lot's changed since I was working on this problem. I found out just recently that I believe Underwriters Laboratory has released not a standard, but a guidance document describing how to test additively manufactured products in the construction environment. And I think just even that little crack in the door is going to make a big difference. But I suspect there's still a long way to go before 3D printing before the regulatory environment to allow you to 3D print an entire house is established enough that just any builder is going to say, oh yeah, let's 3D print this house. I think we've got a while here where it's going to be primarily the provenance of sophisticated architects, startups, and folks with very, very specific requirements, like people who are trying to build shelter and build structures in very challenging environments.
And for one final question, what do you personally enjoy about working in this field?
That's a great question. Yeah, that's a great question. Working in additive construction specifically, or in automated construction specifically, a lot of robotics currently winds up being relatively distant from impacting people for the better. Right, if I build a robot arm to assemble some product or perform some operation in a factory that, then the thing has to go through a long supply chain to get to the end user. It's a fairly distal impact. If I can 3D print a house that somebody's going to live in, that's much more immediate. It touches them much more proximally, and that's very satisfying to me. This opportunity to leverage both the technical skills that I try to develop, alongside this opportunity to impact people directly by building houses for them. It's a really exciting opportunity.
Absolutely. And I want to thank you again for your time and talking to us.
All right. Well, Connor, thanks so much again for the opportunity. I appreciate it.
This has been Arctic 360's Breaking the Ice. Thanks for listening.
And see you next time.